Right. Object-oriented programming. I just run with this slide, but I'll try to give some sort of understanding. Object-oriented programming. This is very powerful concept. This is a paradigm of software development that introduces real-world object attributes and behavior could inject to the program code. Now, sometimes you haven't done any code forever. Sometimes you have done some small piece of code, or sometimes you have developed code well, whatever the level you are. Under this software development paradigm, or the object-oriented programming is focused on the real-world objects. Now, what are the real-world objects? Are chairs, human, dog, fan, flowers. Right? These are the objects, real-world objects. Now, what we are going to do is we are planning or we are extracting the things from the object. What's the object? The real world object. We will get an example of a cat. Right? This cat has mainly two things. First one is there are some sort of attributes. What are the attributes? Are this object can explain by these attributes. This specific object can explain. Right? I will give an example. What are the attributes? Skin color. There's a skin color for all the cats. There's a tail. There's a length of tail. And there's a weight. For each and every cat, there's a weight. For each and every cat, there's a height. So you may realize these are the attributes or the common properties of the object. And what are the behaviors? Behaviors are the activities performed by this object. Again, back to the cat example. This cat would able to run. This cat is eating. Cat is sleeping. Cat is jumping. Jumping, running, sleeping, eating. These are the behaviors that we can express the object. I will give another example. If we get a chair, every chair has a set of attributes. Attributes are the things that we can describe the object. Every chair has a specific height, the specific color, specific weight. Right? We can describe everything. And behaviors, obviously, there's a behavior for chair. We can throw it away. We can throw it. We can break it. We can break it, right? For a chair, we can break it. We can, it's a destroyable or throwable. This object is a throwable object. This object is a destroyable object. Likewise, we can express these things. Right? Okay. Now, these are the attributes and behaviors. Now, object-oriented programming is inject or extract these things to a source code. How? We can say, if you are not program forever, little bit hard to understand what I'm speaking here now onwards, but I'll try to minimize that technical gap in between my speaking and your understanding. Okay? I will define a variable. I'm speaking about Java context. Right? I'm defining a variable called int or double weight. That means there's a variable called weight. It has a data type of double, and for a given specific object, it's depend. I will give an example and make sure the statement is clear. I'm defining double height to 1.3. Now, what is 1.3 means? My given chair is having 1.3 of height or 1.3 of weight. It might be kilograms, it might be grams, it might be meters, whatever. I'm just not going to that much. But for just roughly understanding, I'm defining a specific value. It's a variable. Why it's a variable? Variable means something varied time to time. It's changing. Now, if we get 10 chairs, you might have 10 different heights. If we get 10 chairs, they are different weights. So it's changing according to the object. Right? Now, what we are going to do is we are going to inject this object attribute into a program code. But the program code is double height assigns to 1.3. Double weight assigns to 3.4, whatever. Right? Whatever the thing. PowerPoint slides are there, Puta. There's a question, can you upload the PowerPoint in the Moodle? It's in Moodle. I have uploaded it. So you can download it and you can go through with me. Right? Now, what I have stopped is the object code. Now, whatever the object, different chairs has different heights and different weights. And behaviors, obviously, if we get a very heavy chair, we can't throw it easily, right? We can't throw it easily. If we get a small plastic chair, the baby's chairs, we can throw it very easily, isn't it? So the behavior is changing according to the object, but it's common. It's a chair. Now don't be confused. It's a chair. Yes, of course. It's a commonly we can say it's a chair, but it's varied according to the given specific object. Now what we are going to do is we are going to do this. We are defining a common object, chair, and we are specifying it. This chair is this much of height. This chair is this much of weight. Okay. Now this is the process of object-oriented programming. Java, Python, C++. These are object-oriented programming languages. Now, object-oriented programming is on top of mainly 4 concepts. I just skim these concepts, so you will learn later on, but mainly there are 4 concepts. First one is abstraction. That means we can define an abstract behavior or the abstract nature of an object, or just some sort of skeleton. If we draw a small, if we ask to draw a human, if you ask for to draw a human for a child, I think it's a Montessori baby, small one kid. This kid would draw a skeleton of a human, right? There's 2 hands, 2 legs, and there's a middle area with the head, with the big head. It's an abstract of a human, but we have to accept it because it's the abstract nature of the human. Clear, right? This is the concept of abstraction. And objects, I spoke about object. If you ask you to draw a chair, for me, think I can't draw well, I would draw an abstract chair. It's not a chair at all, right? It's not a chair, it's not a table or whatever. It's just an abstract view. It's very ugly design, but it's acceptable, right? I'm focusing on the main core features that child would draw. Core features: a head, hands, and a small body with a big legs or big head, whatever. It's acceptable. The core features are there to make sure it's a human or a human object. That is abstraction. And polymorphism is the concept of defining same activity can be in, it can be explained by different mechanisms, like polymorphic nature of objects. Some objects do have polymorphic nature. That is, it's like you have like, I'm not sure, some sort of students are from business background, so if I give a chemical example, it might be a problem, right? If you get sulfur hard, right? Sulfur hard, right? There are some what we call, same thing can be in different ways. So please explain this to the business people if they can't understand. That polymorphic of the sulfur, there are different sulfur is there, solid sulfur and other stuff, right? Likewise, uh, so that example will be hard, right? We'll give an example like this. There are things in the same thing, but it's in different mechanism. So I'll give an example, but this is not the perfect example, but for understanding, if you get some sort of plate of rice, it can be fried rice, or it can be normal white rice, or it can be red rice, right? Some three varieties as I'm speaking. There are polymorphic natures. If we get rice, it's rice, yes. If we get specific rice, it can be white rice or red rice. Or if we get another nature, it can be fried rice. The rice is evolved with the different aspects. That is polymorphism. Polymorphism is mainly involved in the programming to make sure the same behavior to be run in different places. Sometimes this might be a little bit hard to understand because since it's introductory program, but try to understand what I'm speaking here. And encapsulation, I will give an example again. Like now, if you want to protect something, you can hide it. You don't want to show your money, how much is it in your hand. What you do is you put your money into a wallet, right? That is hide the information from the outside. You save your money in a bank which is not accessible by everyone. That is encapsulation. Capsules, what the capsules are doing, they are hiding the medicine inside the capsule. Yeah, I know everyone used at least a capsule. So at that case, uh, encapsulation is the process of that performing activity to hide the information from the live environment, or it's not accessible by everyone. Like, think like a small medicine capsule, it's hide the medicine. I'll back again for the polymorphism. Like I'll give the example for you, then you might understand well. Now different rice types are there, right? Red rice, white rice, and different kind of rice types are there, right? Now this polymorphism is the concept of allocating things, or the using the core concept is rice, but it polymorphic, the same thing is in a different view, right? Same thing in a different view. Now polymorphism is like, we will get an example. uh, Now my father can run fast, right? So obviously I can run fast, but in this case, I have different things. Now that example is not fit, that is inheritance. Sorry, I'll give an example like this. I can define the speed of a car by two methods, two mechanisms, by kilometers per hour or miles per hour. Now, the same speed is defined by two mechanisms. The first one is kilometers per hour. The second one is miles per hour. The same thing, right? Same thing known as speed is defined by two methods or two mechanisms. First one is kilometers per hour, second one is miles per hour. The same, I'll back again to the rice example. The same rice concept we can define by two things. First one is red rice, the second one is white rice. The same concept of rice is defined into two things. I hope it's clear now. Polymorphism is defining that kind of situation. Like if you are learning little bit deeper, like there's a method overriding and method overloading. These are the concepts of polymorphism, but I don't want to throw it for you for now, since this is very introductory component. So polymorphism is that, and the last component is inheritance. Now, for real world objects, I'm speaking about the real world objects to inject to the program code, right? It was here. And what is inheritance is inherit things from our super ancestors. I will give again another example. My father can run fast. So usually there's a high probability or common situation I would be able to run fast. My father can think, my father can sing well, and I can sing well back again. Right? You may realize these situations in the singers. Lot of parents, if the parents are singers, their kids or the son or the daughter can sing well. That is inheritance. If the father is a politician, and probably the son or daughter can be a politician, there's a high probability. Right? That's the inheritance. That is real world object. That is a real world behavior. Right? In the same way, the real world object attributes can be inherited. My father is skin color is black. My skin color also black. Why it was happened? Because of inheritance. Right? Very clear, right? Very clear. What I'm going to do is now these concepts, these attributes and behaviors, I'm going to draw in a program code. Now, this is the programming concept that I want to teach you. This is a paradigm, and this is very like it's like a groundbreaking point or the turning point of programming. This is very interesting point.